So good afternoon, good morning, everyone. So today we will solve the exam, major one exam of engineering dynamics. Without further ado, let's begin. So the first problem was a multiple choice question problem. Okay, I hope it was not that confusing as this. So for me, it's not that hard, but I hope you did not have the same reaction as this gentleman here. Okay, so basically 2024, which answer will you choose? A, B, C, or D? Anyway, let's begin. So in the question number 1, we have a particle traveling in a circular path of radius 300 meters, right? And it has an instantaneous velocity of 30 meters per second. And the velocity is increasing at a constant rate of 4 meters per second square. The question is very simple. Find the magnitude of its total acceleration at this instant. So this is a radius R 300. This is the instantaneous velocity V 30. And what is this? What is the rate of change of the instantaneous velocity? Of course, this is AT. This is a tangential acceleration. So in other words, I'm telling you that the tangential acceleration AT is 4 meters per second square. And the normal acceleration, which is V squared over R. So I know V at that instant, 30 square over R, which is 300. So my normal acceleration is what? 3 meters per second square. So you know that when I'm traveling in a circular path, of course, there is a tangential acceleration and there is a normal acceleration. Okay. The tangential acceleration is just dv over dt. Is the rate of increase of the speed. Okay. So if it's a uniform circular motion, of course, the tangential acceleration is 0. Because dv over dt is 0 because v is constant in a uniform circular motion, which is not the case here. Okay. So here, the velocity is increasing at constant rate, and that rate is the tangential acceleration. So what is the total acceleration? Of course, the total acceleration is just the square root of the tangential acceleration square plus the normal acceleration square. Square root of 4 square plus 3 square, and this gives me 5 meters per second square. So C is the answer. Okay, very simple. So in the exam, you don't need to give all the details. You just need to give me the right answer. So C. Question 1, C. Now let's look at question 2. So if a particle is moving in a circular path, again, it's a circular path. The circular path, okay? And I give you the radius. R is 5 meters. And I give you the velocity function, V is 40 square. Find the magnitude of its total acceleration at t equal 1 second. Well, you know that I have a circular path. So basically, my acceleration has 2 components, a tangential acceleration and a normal acceleration, as I said before. So of course, the tangential acceleration is just dv over dt. So I have to take the derivative as a function of time of 4t squared. So this gives me 8t. So at t equal 1 second, so it's just 8 meters per second square. And what's the normal acceleration? Well, normal acceleration, an, at t equal 1 second is just v square at t equal 1 second divided by the radius. So v at t equal 1 second is 4, but you have to take it square, of course, and you divide by the radius, which is 5. Okay, don't forget, v is 4t squared. So v at 1 is just 4 meters per second. So you get a normal acceleration, which is what? 3.2 meters per second square. Now the total acceleration, again, I just use this formula, square root of 80 square, 8 square, plus 3.2 square, and you take the square root. The acceleration at t equal 1 second is just 8.6 meters per second square. So this is the right answer. Okay. Question 2. So B is the right answer. Now let's move to question number 3. So the magnitude of the normal acceleration is always constant? Well, no, of course. An is v squared over r. Okay, v squared is positive, r is positive, so an should be positive. Okay, so forget about sometimes positive. It's always positive because I'm talking about a magnitude. Okay, great. So it's not c. Is it always constant? Wait, an is v squared over r. Okay, so I'm talking about r if it's a circular path. But as I told you, if it's a general path, a curvilinear path, it's v squared over rho. You remember rho being the radius of curvature. Okay, and I have defined how to find rho. Okay, great. If I give you, so rho is just, you remember the formula, 1 plus derivative of y respect to x okay, I think you remember this, right? Okay, the radius of curvature. So the magnitude of the normal acceleration is inversely proportional to the radius of curvature. So that's the right answer. Okay, B is the right answer. It's not always constant because V can be varying and also R can be varying. Good. So it's not always constant. It's constant when I have a uniform circular motion, for instance. It's not sometimes positive, it's always positive. So forget about this. It's not 0 when the velocity is constant. So the only answer is, correct answer is B. So the direction of the tangential acceleration and the velocity are always perpendicular to each other? No. As we said in class. They're always collinear in the same direction or in opposite direction. What do you think? They're always collinear. Okay. Great. They can be in the same direction or in opposite direction. Depends on how I define my origin and what's the direction of motion. Okay. But it's always collinear. And we discuss this in class. Okay. Right. So if the particle has moved from A to B in a circular path in 4 seconds, what is the average velocity of the particle? Well, you know that average velocity is just displacement divided by the time elapsed, the time I took to cover this displacement. So here the displacement is R final, which is RB minus R initial divided by 4 seconds. Great. What is RB? It's the diameter on the x-axis. It's just 10 unit vector along x direction. What is RA? RA is 0, of course, because A is at the origin, divided by 4 seconds. So this gives you 2.5 meters per second along the x direction. So what's the right answer? Of course, the right answer is A. This I'm talking about average velocity. Okay. Okay, what's the average velocity? Right. So if I ask you what's the average speed, you can find it. Okay. Next. So the position of the particle is given by this, or so the x component is 4t squared, and the y component is just minus 2x. Basically, minus 2 times 4t squared. Basically, minus 8t squared. Now I'm asking you to find me the acceleration of the particle. Well, you know that first velocity is derivative of position with respect to time. So what is the velocity along x? The derivative of this. So 8t squared. But the velocity along y will be minus 16t. Sorry, here there is no square, of course. Okay, if you derive this, it just gives you 8t. And the velocity along y will be minus 16t. Okay. Now, acceleration, which is just the derivative of velocity with respect to time, has two components. Acceleration along x, which is just 8. Acceleration along y, which is just minus 16. So the acceleration in unit vector notation is 8 I hat along the x direction minus 16 j hat, the unit meters per second square. So B is the right answer. Next question. I give you the position of the particle is given by this along I hat along the x direction and along j hat the y direction. Find the speed of the particle at t equal 1 second. So you know that the position as a function of time is given by x. So the x component is just 3 half of t squared plus 1. And the y component of the position is just 4t minus 1. Let's find the velocity, which is the first derivative of position with respect to time. Okay, this you know it from physics 101, from physics 110, okay, general physics. So you will have the derivative of this gentleman, of course, is just 3t. And the derivative of this is 4. Now let's find v at t equal 1 second. So this gives me 3 times 1, 3, and 4. So the speed, we just square root of 3 square plus 4 square. Of course, this will give you 5 meters per second. So the answer is C. Next question. So the path of the particle is given by this parabola. Y is half x squared meters. So if the velocity along the x-axis, so I am giving you Vx at x equal 2 is 1 meters per second. Find me the velocity along y at x equal 2. That's the question. So what's the velocity along y at any x? the velocity as just derivative of y respect to time. So this will give you derivative respect to time of half x squared. So here you use, of course, the chain rule. Okay. So you remember the chain rule. So this gives you derivative with respect to time of x times derivative of 1/2 of x squared with respect to x. So this gives you x dot times, now what's this derivative? It's just 2x. But don't forget, of course, if I have 2x, 2 in this half, it will go away. Okay. So if I take the derivative, this 2.5 will just cancel. So I will have just Vx multiplied by x. Now let's calculate what's Vx at x equal to. It's already given, it's 1 meters per second multiplied by x, which is 2. So this gives me 2 meters per second. So the answer is D. So here you just use the chain rule, okay? You remember the chain rule. Derivative of y with respect to x, in this case, will be derivative of y with respect to time. I mean, respect to time here, sorry. Will be derivative of y with respect to x multiplied by derivative of x with respect to time. Chain rule, okay? Y is a function of x, which depend on time, of course. Derivative of y with respect to time is derivative of y with respect to x multiplied by derivative of x with respect to time. That's what we use here, and you know it very well, and we have practiced this a lot in class. Question number 9. If the particle moves in a circular path, so you see here, I have used a lot of circular path at constant speed. So we are talking about uniform circular motion. Now find the radial and transverse acceleration, okay? So here I'm not using tangential and normal acceleration. I'm asking you to find me the radial and transverse acceleration. So I think you remember that. We already discussed that. Okay. So let me just remind you, of course, the vector position in the radial and transverse, yes, basically radial and transverse coordinate system. So the vector position is just r, UR being the unit vector along the radial direction. And for that, you go back to the lecture, okay? I have defined these components, okay? Basically the radial direction and the transverse direction. And from that, we found the velocity. If you remember, the velocity, I told you that the velocity has two components, a radial component and a transverse component. So the radial component of the velocity is just the first derivative of r. And the transverse component, v theta, was just r theta dot, if you remember this. And we proved this in class. And the acceleration as well has two components, a radial component of the acceleration and a transverse component of the acceleration, u theta. And I told you that the radial component of the acceleration, the radial acceleration, is what? And this is given also in your formula sheet. And we derive it in class, r dot dot, second derivative of r minus r theta dot square. And of course, the transverse acceleration is what? We already discussed this, r theta dot dot, second derivative of plus 2 times r dot theta dot. Now, if I have a uniform circular motion, okay, uniform circular motion, like in this case, I'm going through a circular path with a constant speed. Of course, r is constant. meaning r dot is 0. I mean, r is constant, the radius is constant, so the r dot is 0. Of course, r dot dot is 0. So forget about this part here and this part here, because r dot is 0 and r dot dot is 0. Second thing, I am going at constant speed. That means that theta dot is constant. Right? This is constant. So that means theta dot is constant. That means theta dot dot is 0. I'm sweeping the angle, the angular variable at constant speed. So theta dot is 0. Okay. So theta dot dot, which is the second derivative, which is the angular acceleration, is 0. So forget about the angular acceleration, here is 0. So in other words, the radial component is minus r theta dot square, and the the radial acceleration is minus r theta dot square, and the transverse acceleration is just 0. So which one is the correct answer, of course? So of course, the correct answer is C. Okay. A radial is equal to minus r theta dot square, and a transverse, which is the transverse acceleration, is just 0. Okay, and you know this from the tangential and normal acceleration. So here you can go from the tangential normal coordinate system to the radial and transverse coordinate system. You will find the same answer, of course. Next question. So we have a projectile. It has an initial velocity v0 and an initial launch angle of theta with respect to the horizontal. When can we reach the maximum height? Is it at 30 degrees, 45 degrees, 60 degrees, or 90 degrees? Of course, the maximum height will be reached at 90 degrees. Okay, great. But the maximum range will be reached at 45 degrees. Okay. But here I'm talking about maximum height. It's 90 degrees. Okay, so this is the right answer, 90 degrees. Now let's move to the next question here, which is very important. Now in this problem, as you can see, I'm giving you a cump follower mechanism. So in the cump follower mechanism, very important mechanism, the slotted bar rotates with a constant angular velocity of 10 radians per second. So the angular velocity is theta dot is constant, is 10 radians per second. Okay, and it's constant. Well, if theta dot is constant, so that means the second derivative, theta dot dot, which is the angular acceleration, is 0. Simple. Okay. And the radial position of the roller follower A is determined by the following polar equation. Okay, R is equal to 1 plus 1/2 of cosine 2 theta. Okay, so again, R is the radial distance between A and the origin. Okay, it's given here in this R, and theta is of course the transverse, the angle theta between the x coordinate and R, basically the theta of the polar coordinates. So here I have, of course, my polar coordinate, R theta. So R is, of course, my radial distance, and theta is my transverse angle, transverse, like in the previous question number 9, okay? Great. So now when theta is equal to 30 degrees, determine the velocity of A in terms of polar coordinate. So as I told you, R vector is just R, UR. Okay, so this is R vector. So this is a UR, is a unit vector along the radial direction. Let me put it in a different color maybe. Let me put it in blue. So this is a unit vector along the radial direction. I call it UR. And U theta is this vector here. Is the transverse direction, the unit vector along the transverse direction. Okay, great. So if I derive, and we derive this in class, the velocity of A in the polar coordinate will give you VR, UR. You have a radial velocity, but also you have a transverse velocity, V theta, U theta. What is VR? It's just R dot. Okay. What is V theta? Is R theta dot. So in other words, I'm asking you to calculate for me VR and V theta. Good. And to calculate it when theta is equal to 30 degrees. Great. Now, before we do that, what do we do first? Let me take it in green. As you know, theta dot is 10 radian per second. Theta is 30 degrees. Theta dot is 10 radian per second. And theta dot dot is, of course, 0, because the theta dot, which is the angular velocity, is constant. Now let's calculate R when theta is equal to 30 degrees. So it will be equal to 1 plus 1/2 of cosine 2 times 30 degrees. You do the calculation, you will just find 1.25 meters. So this is R at 30 degrees. So basically this distance when theta is equal to 30 degrees is 1.25 meters. So now let's calculate R dot when theta is equal to 30 degrees. So first let's calculate R dot for any theta. Okay, we know that R is equal to this. So R dot will be, of course, derivative of this gentleman is 0 plus 1/2. What's the derivative of cosine 2 theta with respect to time? Of course, it will be 2 times theta dot minus sine of 2 theta. So R dot is just minus 1/2 multiplied by 2, let's go away, minus theta dot sine 2 theta. So this is R dot. This is the radial velocity, or the radial component of the velocity. Okay, at any time. Now I can calculate R dot at theta equal what? 30 degrees. So this will give me minus theta dot sine 2 times. So here, of course, it's not dot. There is no dot here. Okay, because this is a mistake. Let me remove it. So there is no dot here. Okay, forget about it. It's just theta. The dot is here when I derive. So this is just sine 2 theta. Okay, so sine 2 times 30 degrees. So this gives me what? Minus theta dot, which is 10 sine 60 degree. So when you calculate it, you will get minus 8.66 meters per second. Okay, great. This is R dot when theta is equal to 30 degree. Okay. Now, based on that, I can calculate the velocity. So I'm answering to question number A. Velocity at A when theta is equal to 30 degree. Of course, this is equal to R dot when theta is equal to 30 degree multiplied by UR plus R theta dot. Of course, when theta is equal to 30 degree of U theta. So this will give me R dot is minus 866 UR. So R theta dot, well, I know R is equal to what? Where did I calculate it again? R is this 1.25. Now I have to multiply by theta dot. So what is theta dot? Okay, theta dot is just 10. Okay, U theta. So this velocity here I'm looking for is just simply minus 8.66 UR plus 12.5 U theta. Is it clear? Great. So that's the velocity. And of course, you put the units. Okay, don't forget the units, meters per second. Okay, that's the velocity of the follower A in terms of polar coordinates. You do this, you have 3 points. Now the question is, find the acceleration of A in terms of polar coordinates. Well, now you know that the acceleration, let me write it here. So now I'm in question B. The acceleration has 2 components, a radial component plus a transverse component. So what's the radial component? We already calculated this in question 9 of the previous problem. So AR, the radial component, is R dot dot minus R theta dot square. So you remember this? This is the radial acceleration. Now what is the tangent, the transverse acceleration? The transverse acceleration is just R theta dot dot plus 2 times R dot theta dot. Okay, don't forget this. It's in your formula sheet anyway. Good. Now, let's get R dot dot. Let me write it here. So if this is R dot, the second derivative of R with respect to time, R dot dot, is just the derivative of this here. Okay. You do it. We did it many times already. So it gives you minus theta dot dot sine 2 theta. But don't forget that theta dot dot is 0. So this part is just 0 because theta dot dot is 0. Minus, and here you do the derivative carefully, and we have done it many times in class already. So it will just be 2 times theta dot square, don't forget the square, cosine 2 theta. Don't forget this, okay? So in this specific case, let me write it here again, R double dot, which is the second derivative of R with respect to time, is just minus 2 times theta dot cosine 2 theta. Okay. Now let's calculate R dot at theta equal 30 degree. Will be minus 2 times theta dot, which is 10. But don't forget the square, okay? So it's theta dot square here. So I was about to forget it. Don't forget the theta dot square. Very important. So 10 square, okay? Multiply by cosine 60 degree. Okay. If you do the calculation, you just have minus 100 meters per second square. Okay, minus 100 meters per second square. Okay, so let's do the calculation. So the acceleration of A when theta is equal to 30 degree will be equal to minus R dot dot, which is minus 100, minus R, which is 1.25, theta square, which is 10 square, which is 100, UR, plus now A theta. So this, forget about it, it's 0, okay? So it gives me 2 times R dot, well, R dot at 30 degree, we already calculated it. So what is R dot at 30 degree? It is minus 8.66 multiplied by theta dot at 30 degree, which is 10 U theta. So the acceleration I'm looking for is equal to what? Is equal to minus 225 UR minus, so another minus 173.2 U theta in meters per second square. Okay, great. So the velocity is this, and the acceleration is minus 225 UR minus 173.2 U theta meters per second square. Okay, great. So we have solved more difficult problems in class, but here it was just to see if you can navigate through these different component in terms of polar coordinates of the velocity and also of the acceleration. So now let me summarize what we did so far. We found the velocity of the roller A at theta is equal to 30 degree in terms of polar coordinates. So it's equal to minus 8.66 UR plus 12.5 U theta meters per second. This is the velocity. It has 2 components, a radial component and a transverse component. And we found that the acceleration of the roller A at theta is equal to 30 degree is equal to what? Minus 225 UR. This is the radial component of the acceleration, the radial acceleration, minus 173.2 U theta, which is the transverse acceleration, and the unit is meters per second square. So we have determined the velocity and the acceleration of A in terms of polar coordinates. Polar coordinates, okay? That was question A, and this was question B. Now I want to find them in terms of Cartesian coordinates. Okay, the velocity in terms of Cartesian coordinates, but also the acceleration in terms of Cartesian coordinates. So what I need to find is UR in terms of Cartesian coordinates and U theta in terms of Cartesian coordinates. Well, it's very simple. You remember UR here was this. Let me just write it here. UR is this, the unit vector along the radial direction. Well, you see here UR is just cosine theta I hat. So I hat is this, of course. And J hat is this, the unit vector along X and Y, plus sine theta J hat. So I know UR. Okay, in terms of X and Y, basically I hat and J. So U theta being here. So can you find basically U theta will be cosine theta plus 90 degree I hat sine theta plus 90 degree J hat, because I'm adding 90 degree to it. Basically pi over 2. So what is cosine theta plus 90 degree? Of course, this is just minus sine theta I hat plus cosine theta J hat. Okay, so this is my U theta. So now I know U theta and I know UR in terms of I hat and J hat. So I can know my acceleration in terms of I hat and J hat. And I can know my velocity in terms of I hat and J hat. Okay, very straightforward. Okay, so again, let me just write it here. UR, here it's cosine theta, but theta is 30 degrees here. Okay, so it's just square root of 3 divided by 2 I hat plus sine theta, which is 30 degrees, which is half J hat. And U theta is just minus half I hat J hat. So I know the velocity. So I just replace U theta by this value and UR here. So my velocity along I hat and J hat. So this will give me what? Minus 13.75 I hat plus 6.5 J hat. Okay. Same for the acceleration. We already calculated the acceleration. Don't forget the units, meters per second. Okay. This is the acceleration. So this will give me minus 225 UR, the square root of 3 divided by 2, 1/2 J hat minus 173 divided 0.2 U theta minus half I hat square root of 3 divided by 2 J hat. And then I take this and this together, and then I take the J hat together. So at the end of the day, I will have minus 108.23 I hat minus 262.5 J hat. Okay. Of course, this is in meters per second squared. And this I have answered both questions, the velocity in terms of Cartesian coordinate and the acceleration in terms of Cartesian coordinate. So we just find the unit vectors, the radial unit vector and the transverse unit vector in terms of the I hat and j hat, which are the unit vector along x and y Cartesian coordinates. And you just do this change in reference, okay? The change in frame, okay? You go from polar coordinates to Cartesian coordinates. That's straightforward, and you have done that in math. Now let's go to the last problem. So we have a team of engineering students at DAUST who design a medium-sized catapult. So I give you the mass of the steel sphere. Of course, here we are looking about kinematics, so it will be mass independent. So the launch speed is given. So we have a projectile motion here, this object here, and I give you the launch speed, 25 meters per second, and I give you the launch angle, projection angle, 35 degrees. Now in this setup here, so this is 2 meters from the ground. The ground is here. This is 2 meters from the ground. And here I have a fence, and the height of the fence is 2.5 meters. And all the relevant data is shown in the figure. So look at the figure carefully, and you answer the first question. Does the projectile pass over the fence? Prove your answer. Okay, this is straightforward. Okay, you did projectile motion, and we solved it already many times in class. So you can choose the ground here as your origin, but me, I will choose my origin here. So this is my x-axis. You can choose the origin wherever you want, okay? So this is my x-axis, and this will be my y-axis. So my origin is here. Of course, at t equals 0, x0 is equal to y0 is equal to 0. So I choose this to be my origin. So the ground is at -2, okay? Great. Yeah. So the ground being at -2, that means the fence will be at which height from my x-axis? Okay, so if this is 6, this is 2.5, so I am at 8.5 from the ground. Okay, so I remove 2. So the fence here will be at what height from the ground? Can you tell me? So the fence will be at which height from the ground? So it will be at 6.5. So if this is 0, this is 6.5. This is what I chose because I chose this to be my x-axis. So this is just 8.5 minus 2. Great. So does a projectile pass over the fence? You can pass by the time, but here I will pass by the projectile motion equation. Okay, so let's keep going. I had a small technical problem, but let's keep going. So as you know, my acceleration has 2 components. Along x, which is 0, no acceleration along x, and along y, my acceleration is just minus g, which is 9.81 meters per second squared. So the velocity has 2 components, velocity along x. So along x, since no acceleration, velocity along x is constant. It's just v naught x, basically v naught cosine theta naught. V naught being 25 meters per second, theta naught being 35 degrees. And along Y, just minus GT plus V naught Y, which is V naught sine theta naught. Now from that, I take the integral and I go to the position. So the position, the first position, you remember x naught is 0, so forget about x naught. So here you just have V naught cosine theta naught t, and the y will be just V naught sine theta naught t minus half gt squared. So these are the equations that you know already. So here, of course, I don't have x naught and y naught because I take them as my origin. Okay. Again, this is my x-axis here, and that's my y-axis there. Great. So I can use the time. First method. Here you see that I can check at which position, at which x is my fence. The fence is at 40. So the fence here is at plus 40. So at the fence, x is equal to 40. So I can use that. I can say that x at the fence is equal to 40. And then I can find the time. If I do the time, I'll get a time of 1.953 seconds. And then I plug it in the y to get the y at that time, 1.95. So if you do that, you get a y of 9.30 meters. So of course, this 9.30 is bigger than 6.5. So this is larger than 6.5 meters. So I'll go over the fence. So basically this will go over the fence, okay? Because at 40, I will be at 9.30 from here, okay? So this here will be 9.3, and it's bigger than this, which is 6.5. So indeed, I will pass over the fence. Okay. Is it clear? Great. So again, I'm talking about this x-axis here. But if I was looking everything over the ground, so here I will have 11.30, and it's bigger than 8.5. If my origin was from the ground here, if I took this as my x-axis, the ground as my x-axis. Okay. It's just a shift by 2 meters, okay, if you want to. Now, another way to do it without the time is just to write the equation of the parabola. You remember that y is just tangent theta naught x minus g divided by 2 times v naught square cosine square of theta naught times x squared. Okay, this is the equation of the parabola. Now, when x is equal to 40, the y, I just plug here. So I know everything. I know v naught, I know theta naught, I know g, I know x. So the y will be just 9.30. And this is larger than 6.5. So basically, the parabola will be over the fence. So the projectile will pass over the fence. Does the projectile pass over the fence? Yes. Way to prove it, you just need to prove that the y is larger than the height of the fence. Great. Second question. So let me erase this. So the second question is to find the duration of the flight. Now I know that the projectile will go over the fence. Of course, it will hit here. So now the question is, what's the duration of the flight? Okay, I want to find the duration TF of the flight. when it hits this hill here, what is the y? So the y is just 4 meters from this x-axis. Okay, it's 6 meters from the ground, so it will be 4 meters from the x-axis. Okay. So when y is equal to 4 meters, what is the time? So I'll be using this equation here. Okay, so 4 meters or 4 will be equal to V naught sine theta naught. I know V naught 25, theta naught is 35 degrees, multiplied by TF, which is the time of the flight, minus half G T square, which is TF square. So this will give me a quadratic equation. Okay, you can do the calculation. So the quadratic equation is just 4.905 time flight square minus 14.34 t plus 4 is equal to 0. If you solve this quadratic equation, you will find 2 times. Of course, the first time will be the time here. The second time will be the time I reach here. So I want the second time, the larger time. So TF, which is the time of flight, which is the time when I hit this point here, is just 2.61 seconds. Okay. The other time I reach here is just 0.31 seconds. But I don't want this time. I want the time, the larger one. Okay, so I will have 2.61 seconds. Third question. Find the XY coordinate of the point of the first impact, either the fence or the ground. Now we know that the point of impact will be the ground, not the fence. I will go over the fence. So I mean the hill here, not the hill here, this point here. I'm talking about this point here. So the Y coordinate is known already, is 4 meters. 4 meters from this x-axis, but 6 meters from the ground, okay? According to this. So it's 4 meters, Y is equal to 4 meters. And X will be equal to what? Well, I know TF, the time of flight. I'll just use V naught cosine theta naught multiplied by the time of flight. And I'll find that the X is just 53.45 meters. Okay. So this point here is 4 meters above the x-axis, or 6 meters from the ground. And here it will be 53.45 meters from the origin. Great. Now, what's the maximum height? Well, you know that at maximum height, Vy is 0 at maximum height. So meaning I can use Vy square is equal to V naught y square minus 2g y minus y naught. At maximum height, I'll stop moving along the y direction, so this is equal to 0. So meaning y minus y naught at maximum height is just V naught square divided by 2g, which is V naught square sine square theta naught divided by 2g. And you put the numbers, you'll get the maximum height is 10.48 meters. And of course, it's 10.48 meters from my x-axis, but from the ground, I have to add 2. Its maximum height is 12.48 meters from the ground, okay? That's the height from the ground. And this is the height from the x-axis. Is it clear? Okay, great. Now, the last question is to find the velocity expressed as a vector with which the projectile strikes the ground. So the velocity with which the projectile strikes the ground. Okay. By ground, I mean on the hill, of course. Okay. Well, I know TF is 56? No, 2.61 seconds. So I will be using this equation here. So I'll be using which equation? I'll be using, let me do it again. I know TF is 2.61 seconds. You know that Vx is a constant, is V naught x, which is just V naught cosine theta naught, and Vy is just minus GT plus V naught y, which is V naught sine theta naught. So this V naught x, which is Vx, is 20.48 meters per second. And here I have minus 9.81 multiplied by TF, which is 2.61, plus 25 sine 35 degree. And you do the calculation, you will have minus 11.26 meters per second. So V, which is a velocity at this, which is a velocity at this point, is just equal to plus 20.48 I hat minus 11.26 J hat meters per second. Okay, and this is the velocity with which the projectile will strike the ground. That's it for this exam. Well, I hope everyone will get full mark. It was a very simple exam, only dedicated to chapter 12. Now let's see the result. I will tell you what's your grade. Thank you and see you next time.